Hey guys, this is POTD of lead code 921, which is just the extension of yesterday's POTD. Here, a parenthesis string is valid if and only if it is an empty string, or it can be written in the form of AB, or it can be written as A, which is inside the parenthesis. And what we have to return, we have a parenthesis string as in one more you can insert a parenthesis at any position of the string. Okay, for example, this is the string and we can insert opening bracket at exactly first index, closing bracket at the n minus 2 index. So like basically we can insert both opening and closing brackets, and we have to return minimum number of moves required to make s as valid. So s is valid only when it is an empty string, or can be written as ab, where a and b are both having valid parentheses, right? Okay, let us see. So it's how can I say, and here constraints size is actually 1000, so you can give the time complexity as big of n. So as it is a stack based, we can easily use the stack data structure. Of course, parentheses sums are always can be solved with the help of stack, right? So here I have a parenthesis as like this, and I have to return how many minimum number of insertions do I have to take to make this string as valid. So here, as we see here, we have to insert one closing bracket at the end of the string to make the string as valid. See here, as to make the string as valid like this. So we have to use a stack for this. So whenever we are getting the open parenthesis, we have to push that into the stack, and when we are getting the closure parenthesis, so we have to pop the stack. Right now we have size stack size as 1, so that means only the single parenthesis open parenthesis doesn't actually paired with its corresponding closing parenthesis, so we have to add that corresponding closing parenthesis. So minimum number of additions here are 1, so we have to return 1 for this, right? So if we have a string like this, so which is the second example, see here. Okay, so quite opposite to the second example, right? So now we have to use the stack, right? So here, how many additions we have to insertion operations we have to take to make this string as well. So as far as we know, whenever we are getting the open parenthesis, we have to push that into the stack, and when we are getting the closure parenthesis, we have to pop the stack. So, but here the stack size is actually empty and we are getting closing parenthesis. So when we do the pop, we get underflow condition, right? So which we discussed in previous POTD of lead code. So what we have to do, we have to check whether the stack is actually empty or not, and we have to perform the operation whenever the stack is not empty. Which operation? Pop operation. I hope you understand this. So we have to perform the pop operation whenever the stack is not empty. So not empty. Got it? So here it is not empty. So as it is empty, right? So it doesn't have any elements inside the stack. So it is empty. We don't uh, use the pop operation. So, but here we have to return the answer as 3 because we have to insert 3 open parentheses to this corresponding closing parenthesis. So how can we do this? So we can simply take another stack, which we can like another stack 2, and whenever we are getting the closing parentheses, we have to push them into this stack. Got it? So now the stack size is actually 3. So here we have to perform three operations. So we have to return these three, right? So here we have to use two stacks. So one is for open parenthesis and one is for closing parenthesis. So these open parentheses have to deal with correct pair of parentheses also, right? So whenever we have a correct like a valid parenthesis inside the string, so we have it can be dealt by this open parenthesis bracket. So, like if we have a uh, string like this, so like imagine this is a string. So uh, here this is the open parenthesis, so we have to push that into the stack, and now this is also open parenthesis, so push that to the stack. Now this is also open parenthesis, push that into the stack. Now this is a closing parenthesis, so pop the stack, and this is also closing parenthesis, so pop the stack. Now the stack size is 1. So for this, number of insertion operations are actually 1 to make this into a valid parenthesis. But if we have a string like this, so these three are the closing parentheses, right? So then, and so what should we do? We have to follow the name of the approach which we discussed. So whenever we are getting open parentheses, we have to push that into the stack. Okay, so now we are getting the closing parenthesis. So pop it. Now pop it. And here, now I'm here. So I have to increment my iterator. So now I'm getting the closing parenthesis again. So I have to pop the stack. But here the stack is empty. So when I perform the pop operation, I get underflow condition. Stack is a underflow condition, right? So for this, so this is an extra closing parenthesis which doesn't have its corresponding open parenthesis. So we have to put that into closing parenthesis stack. Now the stack size here is 0 and here it is 1. So the addition of it actually 1. So this is our answer. We have to use one insertion operation to make this string as valid, and that insert, inserted element has to be an open parenthesis. Hope you understand this. Let's see the code. See here. So this is the base condition. Whenever the string is empty, I don't need to perform any operation because the string is already a valid string. So I have to return 0 for that. Otherwise, I have to take two stacks and I have to iterate over the string. And whenever I'm getting the character as open parenthesis, I have to push that into first stack. And whenever I get in the closing parenthesis and the stack is not empty, then we have to pop that stack. Otherwise, that means we are getting the closing parenthesis, but the stack is empty here. So we have to push that into a secondary stack, right? So finally, we have to return the summation of the sizes of both stacks. Right? It is accepted. Hope you understand this approach. So thank you for watching this video.